All right, so we are in our last week of the first triad. So that means we have a test this week, and the opener is a pretty good sampling of what you're going to see on the test. The test is just going to be a bunch of equations that you have to solve. I will tell you, not this many of them, or at least not this proportion of them will be fractions, but most of them will be integers, but you'll have some fractions equations to solve on there also. All right, so let's just review that. For the first one, if I want to get the a by itself, what do I need to do to start to show I want to get that a by itself? I'm going to circle that a. Okay, that's just a reminder I want to get the a by itself. And there's another reminder I want to do. Draw the line of equality, exactly. So that line of equality does a couple of things for us. For one thing, it's a reminder that whatever we do on one side, we have to do on the other. But it also helps us organize our work, so we put our equal signs on that line, and we keep our left side and our right side separate from each other. All right, so if I want to get the a by itself, I need to get rid of that -7. How am I going to do that? I heard two different answers. I heard add and I heard divide. Okay, so here's a question we need to ask. What operation is this here? Is this -7 minus, or is this a minus 7, or is it what? It's multiplication, right? Since the 7 is right next to the a, that's multiplication. So to get rid of multiplication, we need to divide. All right? So we're going to divide. And what do we need to divide by? -7. Good. So when we change the operation, so we change multiplication to division, we still need to keep the number part the same. So we divide by -7. Okay? On the right side, those 7s are going to cancel each other out, and that leaves what? And on the left side, negative divided by negative is a positive, right? The negatives cancel each other out, so it's 35 divided by 7? 5. All right, on the next one, we want to get that b by itself. So we circle a variable, draw our line, and how do we get rid of that +7? We're going to subtract 7. So subtract 7 on both sides. On the left side, those 7s cancel, leaving what? B all by itself. On the right side, we have a -4 minus 7, so they're both negative. So are they going to combine or are they going to cancel? They're going to combine. Since we have negatives and negatives, they're going to combine. So if we have 4 negatives and 7 negatives, they're going to combine to get 11 negatives. So we're going to get -11 as our answer. Next one, we want to get the c by itself, so I'll circle that, draw my line of equality, and what do I need to do, or what do I need to get rid of to get the c by itself? Yeah, we need to get rid of the 3/5, so we'll do that by adding 3/5. So we add 3/5 over here, add 3/5 over here, and on the left side, those 3/5 cancel each other out, that leaves c. On the right side, what are we going to need to do? Yes. When we're adding or subtracting, you need to make sure you get a common denominator. So when we have fourths and fifths, what would our common denominator be? 20. So we're going to put 20 on the bottom of both of these. And so how do I change this first one to a 20? 4 times what is 20? Okay. So we multiply by 5, top and bottom, and get what on top? Okay. How about this one? What do I multiply by here to get 20? So we get 12. So it's 5/20ths plus 12/20ths, which is 17/20ths. I'm going to scratch that out so I don't accidentally use it. And we get 17 over 20. Any questions there? All right. We want to get the d by itself here. We'll circle that, draw our line of equality. And we multiply both sides by what? 3/4. So that's d divided by 3/4. To get rid of it, we multiply. So we multiply by 3/4 on both sides. And over here, the 3/4 cancel, leaving what? D. On the right side, what can we do before we multiply that out? We can reduce that, right? What can reduce there? 2 and 4. What goes into 2 that also goes into 4? 2. 2 divided by 2 is? 4 divided by 2 is? Okay, anything else? 9 and 3. What goes into 9 that also goes into 3? 3 divided by 3 is? 9 divided by 3 is? Okay, anything else? Okay, so now we multiply across. 1 times 1 is? 3 times 2 is? Can I reduce 1 over 6? No. You can never reduce a fraction with a 1 in it, right? Okay, next one. What do we need to do to get rid of the 10 over 21 here? I heard somebody say it. We're going to need to divide, right? So this is 10 21st times e, so the opposite of multiplication is division. So we divide by 10 over 21. And on the left side we get e by itself. On the right side we have division, but we can't divide fractions, so what are we going to do? Yeah, we're going to change it to a multiplication problem. So how do we do that? KFC. What does the K stand for? Keep. So what do we keep? Okay, what does the F stand for? Which one do we flip? Okay, that'll become 21 over 10, right? And then what do we change? That's the C. Good. Division changes to multiplication. Okay, now what? Now we can reduce, right? What can we reduce here?
14 and 21.
What goes into both of those?
7.
21 divided by 7?
2.
14 divided by 7?
2.
Okay, anything else?
No.
Okay, what about the 3 with the 3?
You can't.
Why not?
Because they're both.
Because they're both numerators. What about the 2 with the 10?
They can't.
Why not? They're both denominators. Remember, to reduce, one of them has to be numerator, one of them has to be denominator. All right, so since we can't do either of those, now we'll multiply across. 3 times 3 is 9, and on the bottom, 2 times 10 is? Trying to get the F by itself here, so we need to get rid of what? The 5 over 6. And how are we going to do that? Subtract 5 over 6. All right, so we'll do that on both sides. On the right side, those will cancel. Leaves F by itself. How about the left side? What are we going to need to do? Okay, what would our common denominator be here?
6.
Okay, we could use 6. We could also use
12.
12 would be a good one because we get that by multiplying 6 times 2. I like 6 better though because it is the least common denominator. So when we use the least common denominator, then there's going to be less reducing at the end. So we'll use 12. I'm sorry, we said we we're going to use 6, right? So we've had problems like this before. We only really need to change one of them because the other one already has a 6 in the denominator. So what do I do to change that 2 into a 6?
3.
Multiply by 3. And what do we get on top then? 3. So instead of 1/2 minus 5/6, now we have 3/6 minus 5/6, which would be negative 2/6. Done? What do we need to do? We need to reduce, right? What goes into 2 that also goes into 6? 2. So we can reduce by 2 here. And on top, what do we get? Negative 1. And on the bottom? 3. So we get negative 1/3 equals F. Don't forget, guys, when you're working with fractions, to reduce if you can. You always want to check to see if you can reduce. So when we're doing that, we're just looking for a number that goes into the numerator that also goes into the denominator.